Today we are going to discuss diversity, an important topic in wireless communication. To understand diversity, we need to know multipath propagation and fading. By multipath propagation, we mean to say it is a phenomenon in which radio signal reach receiver antenna by two or more paths. Here we see base station as a transmitter antenna, and we have the mobile station that is the receiving the signal through different paths. So there are four different paths, and the signal is being received by the receiver by reflection, diffraction, various phenomena. So when this happens, because of this, there is a change in signal amplitude or phase changes over time. This causes fading. By fading, we mean it is a rapid fluctuation of amplitude, phase or multipath delay of a radio signal over a short period or short travel distance. Diversity is a method in which we develop information from several signals transmitted over independent fading paths. It exploits the random nature of radio propagation by finding independent signal path for communication. And in diversity, we want the strongest signal. We will implement more than one antenna at transmitter or receiver, and whichever antenna will be able to receive a better signal, we will use that antenna on transmitter side or receiver side. It improves coverage capacity and reliability without the requirement of power or extra bandwidth, because we are implementing extra hardware at the transmitter or receiver end. There are various types of diversity. First is selection diversity. In this diversity technique, we select the best signal among all the signal received from different branches at the receiver end. Here we see different antennas, antenna 1, 2 up to antenna M, and we have variable gain. Here M demodulator is used to provide M diversity branches whose gain are adjusted to provide the same average signal to noise ratio for each branch. The receiver branch having the highest instantaneous signal to noise ratio is connected to the demodulator. Here we have different antennas. So, whichever antenna will get a better signal, we will demodulate that signal and that will be our output. Second is feedback or scanning diversity. The problem with first diversity technique was that if we start receiving signal from one antenna and we demodulated that signal, but it may happen after some time some other antenna has started receiving the signal in a better form. So we use feedback or scanning diversity, in which we scan all the antenna signal at a fixed sequence. So if signal is received, it falls below threshold. So scanning process is again initiated. So now when we will be scanning the signals again, whichever signal will be equal to our threshold, we will use that signal now. Maximal ratio receiver combining is a third technique. In this mechanism, all branches are used simultaneously for retrieving the best possible signal related to the received signal. In first or second technique, we are using one of the antenna. In first technique, we check whichever antenna is giving a better signal. In second technique, we go on checking the antennas. But if, for example, we are receiving the signal from a particular antenna with the highest signal to noise ratio, rest of the antennas are idle. But in maximal ratio combining technique, we use all the antenna and we sum all the signals and we make them in phase and then we use them. Fourth technique is equal gain combining technique. This is simpler to implement than MRRC. Here we don't need attenuators and no channel amplitude estimation is done. In this technique, we weight each of the signal branch with the same factor, whatever is the signal amplitude. So here we co-phase all of the signals to avoid signal cancellation. Next is macroscopic diversity, which is used in case of large scale fading. And large scale fading is caused by shadowing. To understand this, see this figure. We have base station 1 and base station 2 and mobile station is near to building. We see base station 1 is close to mobile station. But because of shadow region, we are not able to receive the signal from base station 1. So, our mobile station will instead receive the signal from base station 2. This improves coverage capacity and reliability without the requirement of extra power or bandwidth. Next is polarization diversity. It is a method of transmission and reception used to minimize the effect of selective fading of horizontal and vertical components of the radio signals. Here we use separate antenna for vertical and horizontal signal. Next is frequency diversity. In this technique, we transmit and receive the signal on 2 or more carrier frequencies. This is same way we use FDM, that is the frequency division multiplexing, in which we use separate bandwidth range for different users. But it has a disadvantage that it requires more bandwidth and more receivers to receive the information. Last technique is a time diversity, in which same signal is transmitted over the channels at different times. Same signal. That means if we see the figure, here we have message 1 again and again. For 5 times we are using the same message, and time slots are T1, T2, T3, T4, T5. So we are transmitting the same signal 5 times. And TS is the time spacing between time slots. So if we are transmitting the same signal more than once, for example, the receiver missed one of the signal, but it will receive the signal at another time slot. This also provides diversity or a better signal reception.